Hi everyone, welcome back to my channel. Today we are diving into one of the most powerful tools in data science and machine learning, which is principal component analysis. So before jumping to into the code and math and let's see the numerical example, let me ask you some questions. Have you ever worked with a data set that has too many features, or maybe have you dealing with hundreds or tons of variables, and that how you ask your question, let's see yourself question, how do I apply machine learning for this big data set? So in this case, we have, let's see, principal component analysis. The principal component analysis it's let's see, is classified, or let's see, categorized as unsupervised learning. So if you see this course I'm doing right now, it's supervised learning, this one here, and it's as unsupervised learning. You can see, yeah, principal component analysis, or PCA for the. So what is the main, let's see, goal behind the principal component analysis? It's try to minimize, let's see, to shrink number of features, or maybe extract features reduction, dimensionality reduction. So what are the steps of the principal components, or what are the keys in the principal component analysis? So the first one is variance. The variance is measure how spread our data belong to a particular, let's say, axis, or let's say, principal component. So in the principal component, we try to maximize the variance along new axis, new principal component. And the next one is covariance matrix. We try to measure the relationship between variables in the data set. And the eigenfactor and eigen values. The eigenfactor represent the eigenvalues represent the amount of variance captured by each principal component, and the eigenfactor define the direction of the principal component. For instance, this principal component is in this direction, and this one is in this direction. And if you see here the principal, let's see, or the if you have a principal component in this direction, the other one has to be perpendicular, or to this principal component. So that's why we need to capture all the variance in the data set. And let's now jump a little before this, and the explained variance ratio. So the explained variance ratio, it tell you how much of the total variance is captured by each principal component. This we will see by example. So assume that we have this data set here, feature 1 and feature 2, or x1 and x2. And before this, we need to standardize the data. To standardize the data, we need to calculate the mean and covariance, the mean and variance for standard deviation for the data set. For instance, we have this data here. It's the same as just copy, and we calculate the mean for each feature. Let's say for the feature 1 we have the mean is 6. For the feature 2 we have the mean of the standard deviation. Okay, sorry. This is the mean of the first column, and this is the standard deviation of the first column, of course. For the second feature, we need to calculate the mean and also the standard deviation. And if you see the standard the standard deviation is the value, the features, for instance, 2 minus the mean square plus the second value, for instance, 4 minus the mean, which you call mu, minus 6, and all these divided by number of samples. And we will do it for each features. For instance, because here we have only two features, feature 1 and feature 2, we have only mean 1, mean 2, and standard deviation 1, standard deviation 2. And you can see here, for instance, now we need to standardize the data. We will have, as I explained here, we will have 2 minus 6 divided by the standard deviation. If you can see here, z, we will need to calculate now z for the first features and z for the second feature, the same z. and it's, you can see 2 for the first value minus the mu, which is the mean of the first column, 6, divided by the standard deviation of the first column. And do it for the all features in your data set. I just keep it simple here. Now we need to calculate the covariance. The covariance, as I said, it's just capture the relationship between two variables. And the covariance you can calculate with this equation here, and the covariance is the variance of the Z1 and covariance of Z1 and Z2, and also this one will be the C, and Z2 and Z1, but it's the C. And the variance will be in diagonal, and the covariance will be in the other values, let's say, or cells. And the covariance, we will calculate covariance, just double the values of in this features here, divided by number of features, or maybe number of features not minus 1, because this number of samples is minus 1. But I just keep it like this, 5, and I already did the calculation, so will be hard to change it. And this is for Z1, and you can calculate it for Z2. Now we can calculate the covariance matrix with this formula here, which is Z1 minus mu multiplied by Z1, and this formula here. And after that, we will have the covariance matrix like this. Now from this covariance matrix, we will calculate the eigenvalue and eigenvectors. With eigenvalue and eigenvectors, we need, for the eigenvalue, we need the determination of the eigen of this matrix. So you can see covariance matrix is this one, 1, 1, 1, 1, minus the lambda multiplied by identify matrix. So identify matrix is this one here, like this. For example, we have two features, it will be like this. If we have many features, all the diagonal will be 1 and the other will be zeros. And the determinant of this, it will be this multiply this minus this multiply this, and it will be like this. This is the equation. And you can see after what is the values makes, for example, this term equals 0. If we see 0, this will be 0. If we have 2, of course this term will be 0. So the eigenvalue will be 2 and 0. For now we need to calculate the eigenfactor for each value, for each eigenvalue. So this is the eigenvalue. For the x, for the lambda 1, we have it 2. So we will take this equation here and replace lambda with 2. As you can see here, lambda 1 minus 2, and here's still 1, and here 1, and here 1 minus 2. And this is our, let's see, matrices. We need to multiply this by this, because we have two values, two variables. It will be value 1, value 2. If you have, as I said, if you have many, you will have, of course, many, and of course, the matrix will be big. This is just how to make it simple for you. And if we multiply this row in this column, we will have this equation. Now we will multiply this row in this column, we will have this. And from this equation, if you see, we can say, for instance, V1 is equal V2 in both equations. So that's why we see V1 is equal V2. And for the eigenfactor, we see we just select 1, 1, 1, because V1 is equal V2. You can just do it 2 or 3 or 5, 4. But for let's say simple calculation, we just replace it with 1. For the 2 as well, we will have 1 minus 0. It will be 1, and here 1, 1 and 1 minus 0. And if you multiply this row in this column, and this row in this column, we will have these two equations. And from the calculation, we will see V1 is equal minus V2. And that's why we have 1 and minus 1. For the eigenvalue, we will sort the eigenvalue and eigenvectors. We have 2 and 0, and here 1, 1, and 1 minus 1. So how now we need to transform the data into the principal component. And we to transform the transform data will be standardized data, which is this one here, for instance. We have it in the beginning. This is the normalized data multiplied by the eigenvector. And for the eigenvector in the beginning, we have 1, 1 for the first principal component. It will be z1, this one here, multiplied by 1, and z2 multiplied this z2 multiplied by 1. And now we can see the principal component 1. It will be z1 plus z2. So for instance, this plus this. This we will have the principal component here, principal component 1. If we need principal component 2, we will do this 1 and minus 1, this one here. But this is because we only have two variables or two columns, we just to make it, let's see, simple. And I will select only the principal component 1. I just calculate the principal component 1. If you need principal component 2, it will be the same, but you need to replace the eigenvalues. Now, the total variance, as we said in the we mentioned in the beginning, that eigenvalues, it will be the total variance. So if you go here, I don't know where was this mentioned, but I hope it was mentioned here. The eigenvalue represents the amount of variance, yeah, I can say, captured by the principal component. And now here we have the total variance. Now we need to calculate the explained variance ratio for principal component 1. How much this principal component represent the data. So as you can see here, this is the equation. Lambda 1 divided by total variance. It will be 2 divided by 2, it's 1. So it will be 100%. The principal component analysis is represent the whole data with 100%. This is not the case because we just have a small data set. But in your case, it will be 10%, for instance, 90%, and the next one, it will be 2% or 30%. I don't know. And some other principal components will be 0, so we will ignore this. So now, as you can see here, we reduce the total the two-dimensional data set into one principal component, and we said principal component will capture the variance of 100%, and this one will be 0. Now this is our data set, will be used for the training. And you can see this is sample 1. In the beginning was so we will replace this data here. Let me just copy this and put it down. So in the beginning was this was our data set. Now the new data set will be this one here, and this will be used for the training. We'll feed this into the training in the machine learning algorithm. So, and they have already provided a code for this. So you can see this is in this file you can calculate the principal component analysis either manually or using the Skyline package, and you can see the Skyline decomposite value decomposition. It's principal component analysis. And the principal component analysis is it's a subset, I will say, from the single decomposition value, singular decomposition value. And you can see this is calculated by NumPy, and this is calculated by Skyline. Of course, you will have some differences, but yeah, this is sometimes this is the case. And I think I'm getting the end of this video. So if you have any question, please write it down in the comment below. And if you are not subscribed, please subscribe to my channel and like this video, because preparing this document or this tutorial, it was taking much time. Thanks for watching, and see you next time.